Have you ever tried to master Tetris or pack a suitcase so perfectly that everything just fits? Well, believe it or not, you're actually thinking about volume. Today, we're going to demystify the math behind 3D shapes, from the simplest cube all the way to more complex stuff. So let's jump right in.
You're probably already a volume expert and you don't even know it. I mean, every time you pack groceries into a bag or play a game of Jenga, you're intuitively calculating volume. But how do we actually put a number on that feeling? Well, let's find out.
So, here's our game plan. We'll kick things off with the basics of volume, then we'll get into prisms, pyramids, and spheres. And finally, we'll see how to put all these pieces together to figure out more complex objects you see every day. By the end of this, you're going to see the world in a whole new dimension.
All right then, let's get our bearings. We live in a 3D world, right? So our first stop is to really understand what that means when we're trying to measure things.
Here's the most important thing to remember. Volume is all about the space inside an object. Think of it like this. If you have an empty box, its volume is the total number of tiny little sugar cubes you could perfectly pack inside it. It's really that simple.
This is where people sometimes get tripped up, the difference between area and volume. Just remember, area is flat, kind of like a poster on your wall. It just has length and width. But volume is the entire room. It has length, width, and height. That's exactly why we measure area in square units, but volume in cubic units.
Okay, let's start building our 3D world, one shape at a time. And we're going to start with the foundation, prisms.
So where do we begin? Well, with the most iconic 3D shape there is, the cube. With its perfectly equal sides and square faces, it's the absolute best starting point for our journey.
And the formula for it is just as elegant and simple as the shape itself. You just take the length of one side and multiply it by itself 3 times. That is it.
Okay, so what happens if we take that perfect cube and just stretch it out? Well, we get a rectangular prism, like a shoebox or a brick. The sides aren't all equal anymore, but the basic idea is exactly the same. The formula is probably exactly what you'd guess. Length times width times height. And if you really think about it, a cube is just a special kind of rectangular prism where the length, width, and height all happen to be the same number. So that cube formula, it's really just a handy little shortcut. Now here's where things get really cool and super useful. It turns out there's one simple formula that works for all prisms, no matter what shape their base is. It could be a triangle, a rectangle, even a hexagon.
And here it is. Volume equals B times H. Now that capital B is the key. It stands for the area of the base. So all you have to do is figure out the area of that flat bottom shape, multiply it by how tall the prism is, and boom, you've got the volume. It's a really powerful shortcut that works every single time.
Let's break it down into 3 easy steps. First, just find the area of the base. Second, plug that area and the prism's height into our formula. Volume equals base area times height. And third, just solve it. It's a foolproof method for any prism you can think of. So, we've pretty much mastered prisms. But what happens if we get rid of that flat top and instead have everything come to a single sharp point? Yeah, this is where a little bit of magic comes into play.
So take a look at the formula for a pyramid. You see that first part? Length times width times height? That should definitely ring a bell. But then the whole thing is divided by 3. What's going on there?
That's right. It's kind of amazing, but the volume of a pyramid is exactly 1/3 the volume of a prism that has the same base and the same height. You could even prove this to yourself. Imagine filling a pyramid with water and pouring it into a prism with the same dimensions. You'd have to do it exactly 3 times to fill the prism up. And this awesome 1/3 rule doesn't just work for pyramids. It works for any shape that has a flat base and comes up to a single point. And that includes shapes with a circular base, like a cone.
And there it is again. See the pattern? The formula for a cone's volume is simply the cylinder's formula divided by 3. It's such a simple but really elegant and consistent relationship in geometry. Speaking of cylinders, let's round out our set of basic shapes, and this time we'll focus on the ones that involve circles. So here's the formula for a cylinder, but if you look closely, you'll see it's basically our old friend, the prism formula, just in disguise. The area of the circular base is pi times the radius squared, right? So the cylinder formula is just the area of the base times the height. See? It all comes full circle. And now for our last basic shape, the sphere. This one's a little bit of a curveball.
The formula is 4/3 times pi times the radius cubed, and that cubed part is really important. It's that little reminder that we are deep in the third dimension now.
Okay, now that we have our toolbox full of formulas, we can finally start tackling some more complex, real-world shapes. We call these composite solids, but really, they're just a bunch of our basic shapes all stuck together.
Let's see how this works with something like a capsule. First, you just have to break it apart into its components. You can see it, right? There's a cylinder in the middle and then 2 half spheres on the ends, which of course just make one whole sphere. Next, you calculate the volume for each of those parts separately, and finally, you just add the 2 volumes together. See? It's like building with geometric Lego.
So let's wrap this all up. First, volume is just the measure of 3D space. For any prism, just multiply the area of its base by its height. For any shape that comes to a point, its volume is just 1/3 of the prism version. And remember, any complex object can be figured out just by breaking it down into these simpler pieces.
So I want you to look around you, right now. A simple ice cream cone is, well, a cone with a half sphere on top. A building might be a rectangular prism with a pyramid on the roof. Now that you have the tools, you'll start to see these fundamental shapes absolutely everywhere. So what are you going to measure first?